systems of linear inequalities. So again, I'll just kind of give you the process. So one, we want to graph each inequality on the same graph. Two, by shading each one on the proper side, now we're going to do that same intersection thing again. It's the intersection of all the shaded areas. Will be the solution. Okay? And the way that we're going to check that, we can then pick a point in the area or in the intersection and test. Okay? But basically we're going to have to do this as many times as there are inequalities. This is the process that I did from section 4.4. You write the related equation, you see if it's dashed or dotted, then you pick a point on each side. So we're going to have to do that 2 or 3 times. Okay? And that's what I have there. Let me pick out a good example and then we'll be finished. And if you want to stick around and ask questions or something, then that's fine. I might do a couple of examples, actually. All right, you guys ready? Let's do an easy one first. X is bigger than or equal to 1. Y is bigger than or equal to X. So this is a system. I've got not of equations, but these are inequalities now. So it's a system of inequalities. So for each one, I want to graph the related equation. So what is the related equation? Let's say we want to work for this one. Related for inequality 1 is what? X equals 1. Now what kind of line is the line x equals 1? It's going to be solid, but also what can you tell me about this line? Is it going to be a vertical or horizontal? It's not just a point, it will be a line. It should be a vertical line going through x equals 1, and you guys told me it's supposed to be solid, right? So I'm going to draw that. Now, solid. So step 1 for, I'm still just doing one at a time. Step 1 for this one, step 2. Now step 3 for this one is I have to pick a point on either side of the line. What's an easy one to test? 0, 0. Now when I plug it in, I'm going to pick 0, 0 to test. What do I need to plug in? Just x is 0. It doesn't matter that there's no y in this equation or this inequality. All I have to do is plug in whatever my value for x is. So when I plug that in, 0 is greater than or equal to 1. Is that true? No, this is false. So what side do I shade? Right, and it even makes a little bit sense, right? Because if we're saying x goes in this direction, left or right, and I'm saying x has to be bigger than 1, I know that it has to be on this side. So I know that I'm going to shade everything on this side. Now I'm not going to shade the entire right-hand side. But these marks let me know that that's what I mean. Okay, I could, if I had crayons or if you had a pencil, you could shade all that. But I think there's a better way, and I want to demonstrate that for you. Okay, so that was the first one. What about this one? So for 2. What's the related equation for 2? Y is equal to x. Now what does the graph of that thing look like? That was one of your basic functions. That was one of the first videos I did, right? Y is equal to x, or f of x is equal to x. And it's just the 45-degree line in this direction. Everybody remember that? Okay. And it is solid. I sort of skipped that step. I got lucky. It is solid. Now what do I need to do? I need to pick a point. Now when I test it, I want to test it whether it's on this side of this line or the side of this line. So what's a point you want me to pick? Remember, I'm testing this line. So I need to pick either something over here or something down here. -1, 1. Is that okay? So pick -1, and you guys can pick any number you want. And I want to plug this in. Now, this is where you have to be careful. What is my x and what is my y here? X is my -1. Y is my +1. So when I write this equation, or this inequality, y is bigger than or equal to x, y is going to be 1, is bigger than or equal to a -1. Is that true? Is 1 bigger than a -1? Yes, this is true. So what side do I shade? This side, right? Now, remember what I said on the first page. So we shade each one on the proper side. That's what we just did. Now it's the intersection of all the shaded areas that will be my solution. So my solution, or the proper graph, is where is this going to intersect with this? So you can kind of look and see where all the different, these are called normals actually, where these things point into the same thing. So it'll be all this. Okay, now if you use a couple of different colors of crayons, you can see it a little bit better. That's how your book does it. Any questions? No questions. You guys are itching. I know. One more example. One more example. So how about y is bigger than -1. No, there'll be actually equations that you'll have to solve and simplify. It's in this section. You want one like that? I was trying to make it simple. Yeah, let me give you one where you have to do a little bit more work, to be fair. I'll do one out of your homework though. 3y minus 5x is less than 0. 5x minus 3y is greater than or equal to a -12. So the first thing that we want to do, probably the easiest thing, is to just solve for y. Because then you can know that your form y equals mx plus b, you can pick out your intercept and just go up and down the amount of slope. And that's an easy way to graph a line. Okay? So I would probably just solve for y. If I did that for the first one, then I see that I get y is less than 5/3 x. And everyone go from here to here. I added the 5x over, and then I divided by 3. Any questions? So just for the first inequality, I added 5x, so 3y is less than 5x, but then I divided by 3 to get my y is less than 5 divided by 3x. For this one, I'll go ahead and take a couple of steps. So the first thing I want us to do is subtract 5x. So I have negative 3y is greater than or equal to a negative 5x minus 12. All I did was subtract 5x from both sides of the inequality. Now I want to divide by negative 3, so I get y is less than or equal to. So I divided by a negative 3 here. So I have to change this sign. And then it's going to be a negative 5x over negative 3 minus a 12 over negative 3. Simplifying this a little bit more, I get y is less than or equal to, well, this is the same thing as a positive 5/3 x. Remember I talked about negative 1 divided by negative 2 is just 1 over 2. I did something like that. So I've got negatives on the top and bottom here. Same thing here. So this is plus 4. Any questions? All right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 1, 2, 3, 4. This line, what's my intercept? 0. So none is going to be at the origin. What's my slope? So I'll go up 5 and over 3. And is it going to be dashed or solid? Dash. So I'll go up 5, 1, 2, 3, 4, 5, over 3. 1, 2, 3, 4, 5, 1, 2, 3. There's the line, or there's the point. Now I can go down 5, 1, 2, 3, 4, 5, and then left 3. There's another point. Dashed line. Okay, so this inequality gave me this line. What about this one? Well, what else do I need to do? Going back to my steps. For each one, I need to now pick a point, right? So what point do you want to choose here? I'm just going to go with some negative 1, 1 again. Pick negative 1, 1. I'm going to test it here. So my x is negative 1, my y is 1, is a 1, is my y, less than a negative 5/3. Is 1 smaller than a negative number? No. So what side do I shade? Well, I picked on the left-hand side of this line, and it failed the test, right, when I plugged it in. So it's everything to the right. So it's all this. It's getting late, I know. I know. What's my intercept for this line? Positive 4, so it's going to be 1, 2, 3, 4. It's going to be up here. My slope is the same, so I go up 5, 1, 2, 3, 1, 2, 3, 4, 5. It's going to be up here somewhere. But I'm going to go down 5, 1, 2, 3, 4, 5, and then over 1, 2, 3. And this line's going to be what? Solid. Okay, now I need to pick a point on either side of this new line. What's an easy one in this case? Pick 0, 0. Plug it in. I have 0 is less than or equal to 5/3 times 0 plus 4 is 0 less than or equal to 4. Yes. So then I would shade in this side, again, the right-hand side, this line. Now what's the intersection of these two areas? Not quite all of it. Maybe on Thursday I'll bring some transparency paper and it might be a little bit easier to see. But everything, I'm going to try this with color. It might get kind of messy, but let's see if we can see it. So for this line, it was everything over here, right? It was all this, everything to the right of that line. Now for this line, it was everything to the right of the dashed line. Right? Everybody okay? Now what's the intersection of these two areas or these two spaces? Everything that's both green and blue. So it's all this, not green and blue, green and red. It's green and red, I'm sorry. Green and red. So it's all this stuff, right? So your answer would be all of this. Now the trick here, though, is what about this line? Would it be dotted or dashed still? Dotted, because it does not include. It's not in, the line is not included, right? So it would still be a dotted line. Your answer would be this line, dashed, and then all this shaded. Okay? So these are going to take a little bit of practice, a little bit of visualization. You have some colored pencils or family that might have some that might be helpful. Not necessary, but might be helpful. All right, I'll give you your homework. Any questions?